What is up, guys? In this video, we'll be continuing with queues. All right. So we initially talked about queues in stacks, and now we'll be talking about queues. So a stack was a last in, first out data structure, but a queue is a first in, first out data structure. Right. So let us actually draw that and see what that looks like. Okay. So basically, if we have a queue, and we add an element inside our queue, and I'll call this A. And then we'll add another element, B. And then I'll add one last element. Ooh, sorry about that. Call that C, right? Basically, it's a first in, first out structure. So what was first in our array was A, right? So A was the first in that went in. So since A was the first element that was in, it's the first element that will go out, right? So it's the same thing as queuing in like a restaurant, in a fast food place like KFC or Burger King or whatever. Like you're queuing there, so the first person who's there will be able to make the payment and place the order and then leave, right? So similarly, that's how a queue works. It's a first in, first out approach, all right? So then now the next thing to talk about is what are the different operations we can do with it. So we can insert an item and we can also remove an item, similar to a stack. And also, it's not necessarily a linked data structure, but it can be implemented as a linked list. So we'll be doing linked list in the future. Data items are retrieved in the order in which they were placed in the queue, right? So like in a stack, if we place an item at the top, right, and an item at the last, since it's a last in, first out approach, we would have to print the array in reverse, right? We'd have to print the stack in reverse. Similarly, for a queue, for a queue, it's not similar at all. We just print it in the order that we expect and we want, right? Awesome. So the queue operations, data items can be inserted at any time. Only the element that has stayed the longest in the queue can be removed, right? And one can enqueue or dequeue a data item. So similar to push and pop, we can enqueue and dequeue, right? So you can add items with enqueue, you can remove items with dequeue. One can also look at the front of the queue. So similar to peek, there's the front method, right? You can look at an item in front without removing it. One can also check whether the queue is empty, all right? So for the queue implementation using an array, we will create a size we'll create an array. So similar to stack, we'll create an array and we'll create a queue of size n, and then we'll instantiate a variable b back maybe to indicate last element in the array, right? So b is going to equal to -1 initially, right? Because initially there's nothing in the array, right? And then the operations will be size, empty, front, enqueue, dequeue, right? So size will basically return b plus 1. So b plus 1 means since we're tracking the backmost element in our queue, b plus 1 will return the size of the array of the queue. And then we'll check empty will check if there's a top element. If b is less than 0 or equal to -1, it'll return true, right? If it returns true, it's empty. If it returns false, it means it's not empty. And then for front, it's just going to check if there's an element at the top. And then for enqueue, it's just going to add an element into our queue, right? And how it'll work is that first things we need to do is we need to check if b is less than the size of the array. So that's actually something that we haven't been doing in our examples, and I'd like to leave that as a challenge to you guys. Because we're dealing with an array and arrays are not dynamic, if we add an element and like it's beyond the size of the array, we're going to get an index out of bounds error, right? So it's really important that you also cater for all these different edge cases. And what is happening when we enqueue the item? First, we're checking if it's within the size of the array. If it is, we're adding the element, so the back position changes to the newest element. And then we're going to just assign the newest element with the object that's been added, right? And then dequeue, again, we need to check if the array is empty. If the array is not empty, we're going to return the first element. So since it's a first in, first out data structure, the first element is always just going to, if we do queue of 0, the first element is always what's going to be removed. So that, like for front, we will just look at the first element, right? So that's the cool thing. And then we'll of course just change the reference of back, right? Because once we remove an element, we have to do b -1. So you can see that over here, what we're doing is we're assigning the last most element because we've removed an element now, right? The first person is out of the stack, right? So basically our last element, right, becomes the element before that, right? And we can still use this, like since the first element is out, we'll just change the b variable and then we don't have to ever access the first element, right? So basically our B variable will just change to the item there, to the item before the last one, right? So that's basically how we would do the dequeue functionality. I think what we'll do is similar to how we did the stack implementation. Let's also do the queue implementation. We'll code it along together. We'll actually copy paste our stack implementation, and we'll create the queue implementation using an array. So I'll see you guys in the next one. Cheers.